If you've been keeping up with our videos about Uranus, you may be scratching your head wondering what the heck is going on with the planet's weird mantle. So let us talk about the latest findings about the icy mantle and what they mean for understanding this sideways planet. Uranus has intrigued scientists since its discovery in 1781 because it's totally weird. It's the only planet in the solar system that rotates almost perfectly on its side, and it has an unusual magnetic field that makes no sense given its internal structure. Scientists think the key to both of these mysteries may lie in the makeup of its mantle, a layer of rock and ice around the planet's core. But here's the thing, we don't actually know what's there. In fact, all we really know about the mantle comes from one single paper, published more than 30 years ago. That's because we've never sent a probe out there to study it. In order to understand why scientists are so baffled by Uranus's mantle, first we need to talk about how they think the planet formed in the first place. Like all the planets in the solar system, Uranus began as a massive cloud of gas and dust that collapsed in on itself as it began to spin. As the cloud collapsed, the growing pressure and heat would have melted rock and ice, forming a hot, dense core surrounded by a slushy mantle. But unlike Earth, where the inner mantle is mostly solid rock, some of Uranus's mantle could remain frozen, forming a thick layer of water, ammonia and methane ice. That's the most popular theory, at least. Other scientists theorize that Uranus's mantle is completely liquid, or that it has layers of alternating rock and ice. The problem is that scientists too agree on what the actual composition of Uranus's mantle is, because they don't have any real evidence. They're relying entirely on computer models and inferences about how planets form. Basically, it's a lot of educated guesses. So in the late 1980s, scientists used data from Voyager 2 to estimate the density of Uranus's interior. And their conclusion was that the mantle could contain around 10% water ice by mass. This led to the current consensus that Uranus's mantle is a slushy mix of ice and rock. But in 2014, another team of scientists re-examined the same Voyager 2 data and came to a very different conclusion. They argued that if Uranus had formed like Earth, then its mantle should be entirely liquid. The issue, they argued, wasn't the pressure or the temperature, but rather the composition. The first team assumed that Uranus's mantle was mostly made of heavier elements like iron and nickel. But the second team pointed out that those metals could have been incorporated into Uranus's core instead. If that's true, then the entire mantle could just be made of ice. However, they also ruled out the possibility of a pure water mantle. That's because it would have too many dissolved minerals, which would lower its melting point. Many scientists believe that a global layer of ice could be blocking Uranus's core from generating a magnetic field. The core is probably a giant ball of metallic hydrogen that acts like a dynamo, generating a magnetic field as it spins. But if that's the case, why doesn't Uranus have a strong magnetic field like Jupiter? Well, a thick layer of ice could prevent the magnetic field from escaping into space. However, other scientists argue that a water ice mantle would also explain Uranus's oddly tilted axis. You see, for something to push against while spinning, an ice mantle needs support from below. One idea is that the support could come from the atmosphere directly. Early in Uranus's history, intense storms may have created a permanent tilt in the atmosphere that the mantle conformed to. Another possibility is that a giant impact knocked Uranus off its axis. This wouldn't have affected the mantle if it was rigid enough, but it would have caused the liquid part of the mantle to shift and freeze in a new orientation. But regardless of how Uranus got knocked over, if it was once upright, scientists believe a water ice mantle could have frozen in place and prevented the planet from standing back up again. There's also the issue of Uranus's rings. All of the major rings of Uranus are opaque and only a few miles wide, which suggests that they formed out of a sudden, dramatic event. A large body of water ice suddenly released from the planet could have formed the rings, but scientists aren't sure what could have caused that. It could have something to do with Uranus's unusual atmospheric composition. Unlike Earth, Uranus's atmosphere doesn't have much oxygen, meaning that it lacks ozone, which is the gas that normally creates Earth's insulating ozone layer. Without an ozone layer, Uranus's surface could have been bombarded with energetic charged particles from the sun. And if those particles hit the water ice on the surface, they could have broken it down into hydrogen and oxygen. The hydrogen would have formed a thin atmosphere, while the oxygen combined with rock from the surface to form new minerals. That could have caused a chain reaction that melted the entire mantle and allowed all of the water ice to escape into space. Scientists theorized that this water ice could have collected in the rings and then rained back down on Uranus, forming the thick ice layer we see today. However, there's another possible explanation for Uranus's odd magnetic field and its rings. In 2020, a team of scientists proposed that Uranus's mantle might be a layer of water and ammonia ice that conducts electricity. If that's the case, then Uranus's magnetic field could be generated inside this thin ice layer rather than inside the core. An electrical current flowing through the ice could create its own magnetic field, which would explain why it's so weak. And the rings themselves could be explained by convection currents in the ice layer. Warm ice near the equator would rise up and cool towards the poles, creating Hadley cells that would transport energy and angular momentum throughout the planet. Now, the problem with this theory is that no one has observed a similar phenomenon anywhere else. On Earth, water ice becomes electrically conductive only under extreme pressure, and while Uranus is far from Earth, it's still not under that much pressure. Ammonia is more conductive at lower pressures, but a pure ammonia mantle would have serious issues. First, the swings in Uranus's atmospheric pressure would cause the mantle to constantly expand and contract. Second, ammonia ice is very volatile, meaning it would quickly evaporate into Uranus's atmosphere. But if Uranus had an ammonia water mantle, then the two substances could stabilize each other, creating a thick ice layer that's more resistant to changes in pressure. The team estimated that the ice layer could be as much as 100 miles thick, which would be enough to block the magnetic field from escaping. They also suggested that the magnetic field generated in the mantle could interact with the atmosphere to create Uranus' rings. However, this is still speculative, and there's no proof that such an ice layer exists. Not only that, but this proposal goes against the prevailing idea that Uranus and Neptune formed from the same disk of gas and dust. If that's true, then Uranus shouldn't have much ammonia in its mantle. But until we get confirmation of the exact composition of Uranus's mantle, it's impossible to know for sure. In the end, it may just be a combination of everything. We'll have to wait until we have hard evidence to put all of these pieces of the puzzle together. But fortunately, we won't have to wait too long. NASA plans to launch the first Uranus and Neptune probe called the Neptune Odyssey in the 2030s, so stay tuned. Thanks for watching this episode, which was brought to you by our patrons. Our patrons also get access to a monthly podcast, a patron-exclusive video series, and our private Discord server.